Right, guys, in this video I'll be explaining um a simple analogy that has to do with the thalamic nucleus, their function, and how they are related to the cerebral cortex. I'll be making use of a simple analogy, something very funny though, which is the model of a car. This is just a simple model, so this thing is as basic as possible. You can draw this car ideally, you get. So the essence of doing this video is not for you to cram those various nucleus, but actually a very simple way to memorize and remember them. So now let us get a very good picture of what I just drew. So now this is an expanded image of what I drew. So coming to the front part of the car, we have the anterior nucleus. Now the anterior, from the word anterior, it means the front part, right? It means the front part. So in this front part, that's where you have the ng, that's where you have the ng system of the car. So since this is where the ng system is located, it means that it should control the memory of the car, the behavior of the car, and the emotions. So you just try to represent this car or relate this car to the thalamus. Okay, so it is the site where it controls the memory, behavior, and emotion. And how it is related to the cerebral cortex, I made use of a very simple mnemonic, which is LHC, low heat combustion. So the low heat combustion is something that is associated with most automobiles now, like they don't really burn heat like that. So the L stands for the limbic system, because the limbs of the car, which are the tires, they are controlled from the ng, the steering. So and the steering is directly associated with the azu. Then we have the hippocampus and the cingulate gyrus. All right, and the cingulate gyrus. So immediately we are going to move to the next part, which is the ventral posterior nucleus. The ventral posterior nucleus. Now, from biology, the word ventral means the belly, the ventral part of a fish. So it means the belly. So it means that under of this car is the ventral, and posterior means after a particular mark point. So I drew a center line here which divided this car into two parts. So after this part, it means that the next part at the ventral point, you get, that's what we are discussing, which is this part, and it is responsible for relaying sensory information from the receptors to the CNS, like pain, touch, and the rest. Now just imagine that this car entered the gallop, and what part of the car do you think will touch the ground? Is it not the ventral part? Yes, that's the ventral part. So you can just use that to remember the function, that it relays sensory information from receptors to the CNS. So what are some of those sensory information, like pain, touch, pressure, and the rest? And it communicates via the thalamocortical pathway. So just before the ventral posterior, it means that at the medial line we have the ventral posterior medial part. You get, we have the ventral posterior medial nucleus. So it is just similar to the posterior, just that this one is at the medial. Okay, now let us look at the ventral posterior medial nucleus. It relays somatosensory information. So somato means body, sensory, touch, information. However, just like the relation it has to the cerebral cortex, that is the ventral posterior, this one also have a relationship to the cerebral cortex via the thalamocortical pathway. All right, now there is another one that I need to bring to your mind. Now between here we have two doors of the car. We have two doors of the car, and this is the medial line. So we have the dorsomedial. All right, you can just use that to remember it, the dorsomedial, between the two doors. So between the two doors, you can see that this medial line, which is the dorsomedial, is in between the two limbs of the car, which are the tires. So it is somehow related to the limbic system function. And regulation of emotion. All right, regulation of emotion. Now, how does it communicate with the cerebral cortex? It communicates via the prefrontal. So this part is before the front. This part is before the front. The dorsal media, it is before the front. So however, it communicates with the prefrontal, right? With the prefrontal, and it has a connection with the limbic system, just like we said before. All right, now the next part, you don't need to cram. The next part that we need to move over to now is the ventral anterior nucleus. All right, the ventral anterior nucleus. Now we said earlier that this is the anterior, so any part that is ventral, that is the belly, the base of the car, but at the ventral position, you get. So that is what you just used to remember, the ventral anterior. So the ventral part that are under of the anterior. So it means that this one now we have a similar function with the anterior part. Let's just take a look. Now the ventral anterior nucleus, it involves a motor function and relay of basal output. So at the base, for example, maybe the base of the car come in contact with the ground, is going to transport motor functions. All right, transport motor functions. Okay, and how does it communicate with the cerebral cortex? It communicates within the precentral gyrus and other motor area of the cortex. Okay, just like the name indicated, the motor area of the cortex. Now, aside that, we now have another part which is the ventral lateral. It means that the ventral part, the lateral simply means both side, like front and back. All right, left and right. So the ventral, the base, and the lateral, the left and right parts. So it is involved in motor planning and coordination. Actually, these places are kind of balancing, you understand? So when the car is like, maybe for example, the driver want to overtake, when you move, the car will swerve to the left, you shift to the right. So that is why it is ventral lateral, left and right. When you want to overtake, the motor will now swerve to the left and right. That is the motor, that is the ventral lateral, and it is involved in planning and coordination. You can relate this planning and coordination to balancing. So it also connects with the motor area of the cortex. Now this motor area, just remember now, the simple analogy of a car engine is simply a motor. I don't know if you remember a motor system in physics. Okay, I don't know if you remember a motor system in physics. Okay, it's just like the motor. This way you have the radiator, so anything around this part has a connection with the motor system, you get. So also connects with the muscle area of the cortex. Now let's move back a little bit. You see, just above the ventral posterior, we now have the lateral posterior nucleus. Remember, we are just coming from the ventral lateral, but this one is no longer the ventral. It's now like the lateral of both sides. It means the side, this part of the car, and the other part of the car. I just hope you understand what I mean, like both parts of the car, the left and the right side. Okay, that is the lateral posterior nucleus. Now they are also involved in somatosensory procession and integration. Now remember, I said this one is left and right, and when I made mention of the lateral, I actually made mention of I used the analogy of a car that is overtaking another vehicle, so it swerves to the left and right. All right, but just use this analogy that this part, which is the ventral posterior, this one is just above the ventral posterior. It means if this part, the ventral posterior, come in contact with the ground, this lateral posterior nucleus will also be affected. So it also involved in somatosensory processing and integration. And if you remember, the part of the brain of the cerebrum that is related to touch is the parietal lobe. So it is associated with the parietal cortex. All right, it is related to the parental cortex. Okay, now there is one other part which is very, very sweet and interesting, which is the pulvinar nucleus. Now You can just use another way to remember this, which is the picture nucleus. Imagine this is the driver. Maybe this is Tinubu that is driving the car. The place that the driver will be able to like view information from, see things that are happening, is it not from the windscreen? So you can just use this windscreen to remember it, like the posterior nucleus. All right, the picture nucleus. Now let us see the function. It plays a role in visual processing, just like we said, picture, integration of visual information, and attention. Now it has a connection with the occipital lobe of the cerebral cortex, with the occipital lobe. All right, and you know that the occipital lobe is the part of the cerebrum that has to do with association with visual informations. All right, now let's come back. Then we have the medial geniculate nucleus. Okay, this one, there's a way I did it. Now if the driver is sitting down in the car, you know the driver's seat is usually within this medial line, right? And imagine another driver is shouting at the back, hey, oh yeah, oga, you come off for road now, I want overtake, wetin dey build this nonsense. How will the driver hear? Is it not from this medial part? When the windscreen is wind down, so the information, the sound will enter through the windscreen at this medial part to meet the driver. Okay, so anything that is related to noise, the medial geniculate, it has to do with auditory functions, and how it communicates with the cerebral cortex is via the temporal lobe. Okay, and the last but not the least, we have the lateral geniculate nucleus. The lateral geniculate nucleus. This one, just take it to be remember this one, just take it to be the side mirrors. Okay, now what does the side mirror do in a car? The side mirror, you actually use it to view what is happening in the rear. The driver will use it to know what is happening at the rear, that is at the back. So we have the lateral. Why is it lateral? Because we have the two glasses at both sides, at the left and at the right position. Okay, we have it at both sides, that's why it is lateral. So the lateral geniculate nucleus. Now let us see the function. Now the lateral geniculate nucleus, it relays visual information from the rear, that is the retina, from the rear retina to the primary visual cortex. Let me just say the primary visual cortex is the primary driver, your eyes, you get. So just remember it like that. It relays visual information from the rear, that is the retina, to the primary visual cortex. And how is it connected to the cerebral cortex? This connected to the cerebral cortex via the primary visual cortex and the occipital lobe. Okay, this is just a very simple way to understand it. Thank you very much.